All right, hello everyone, it's November 18th. All right, let's get to it. Reduction operation to make an array elements equal. Given an array elements, your goal is to make all elements in nums equal. To complete one operation, follow these steps. Find the largest element, let its index be I and its value be largest. If there are multiple elements with the largest value, pick the smallest I. Find the next largest element in nums strictly smaller than largest. Then its value be next largest. Reduce nums I to next largest. Return the number of operations to make all elements in num equal. Sort it, and then we do some stuff, and then it should be done. I do not think this is difficult, but let's draw it out. So the first one is 1, 3, 5. Right, we find the largest, second largest, and then we'll reduce the nums I to largest. So this will be 3. So that's one operation. And then now this is the largest. So this brings to 3. So 2 operations. And you tell me it's 3 because I cannot sort. That's why. All right. If it cannot sort, now we make this problem a bit more interesting. It's tougher, right? Yeah, it cannot sort. Okay, so I cannot sort. So basically, this is the largest. This is the second largest, so we bring this to 3. That's 1. And then what? This is the largest. This is the starting largest. So this one become 1. And then this is the largest, the second largest, this one become... Oh, that is more interesting. This is easy. This will just go from right to left. We're done. But yeah, you cannot rearrange them. Well. While you cannot rearrange them, but we can sort them no matter what, right? So 5 will definitely become 3. All right? 5 will definitely become 3. And each 3 need to become 1. Yeah, 1 cannot become 3. So we can sort them, right? We can sort them. And isn't each one is just... Right, you sort them, okay, A0, A1, all the way to AN, right? So you sort them increasing. And then you can go from right to left, find the first one, right? So we have duplicates, find the first one, and all of them need to change to this, then to this, right? Am I thinking it right? Everyone has to change. So the largest value need to first change the second biggest. Yes, you need to find the second biggest, and then you need to change. And then according to this, you will change first to this one, right? And you can change the second one. It's just that each one has to change. Once you change, each one has to change. So all of them need to change, right? So the count of them change. Right, and then once they change, we will add to the previous, right, and then they will change the next one, add to the previous. Therefore, what we're looking at, okay, what we are looking at is the number of unique values. That will determine how many times these will change. So we might as well just do a map. Okay, I think I do a map. It will be easier to deal with. So we do a map. We have unique, right? Unique, all the unique, and then we have a count, right? We have a count. And then for the largest the total operations will be the number of unique values, and then times the count, because they have to go every single one. And then we do this, the same thing. We do this, the same thing. So let's write it up and give it a shot. Okay, so I do need a map of integer and integer. So counter equals new hash map. Okay, then for all I need is n. Right. Okay, say counter dot put. Put n counter dot get or default n 0 plus 1. Okay, so now we have the counter. Now we have the keys. We need to sort it. Right? We need to sort the keys of this. So I can say counter dot key set. Can we say new array list? Nah, I don't like it. I think I can just say list integer equal sorted keys. Sorted uniques equals new array list, right? And then we say for int key of key set. Sorted this dot add key, and then collections dot, maybe I have this one dot sort directly. Sorted dot sort. Ugh. How about collections dot sort? There we go. So we sorted. Next, int res equal to 0. For int I equal to sort uniques dot length size minus 1. I large equal to 0. I plus minus minus. And for each one, we'll have res plus equal to counter dot get sorted uniques dot get I. Oh, this probably I can have an easier way. Yep. At all. Oh, I can do even better. Nice. This is nice. Right, so count dot get, this is the count, right? Times, how many times we need to, like, if we have 3 values, 0, 1, 2, so it has to go to 2, right? Go once, go 2, so it's times I is the number of times that you will need it to match to the minimum, right? So we do that, then go to the previous one, go to the previous one. So maybe I can do this. Down here, return res. Let's see if this logic is correct. Looks to be right. I'm gonna throw in some of my secret sauce. Wait, what happened to your... That's good. That looks like we might have gotten it correct. Okay, I think I want to write. Okay, let's write a little bit. Count the numbers, sort the uniques, and for each unique, the number of operations to bring all the values down to the main value is counter unique times index, where the index is the unique's position in the sorted uniques. My goodness. Alright, so on plus n log n. So I have a sort. Try this. Okay, we passed, but it's kind of slow. Usually this slow means we're doing something unnecessary. What do you think? I mean, in this method, I do need everyone, right? I have to. Or can you say like for each value, we can try to find how many, then we need to know how many uniques there are before it. All right, let's see the solution. Sort and count. So you sort and you go from large to small. So we can go but how many do you know? Sort. Hold a second. Okay, we'll go. The first time is not up plus plus. Every time it's not the same, up plus, but this is counting the number of uniques. Oh, yes. This is counting the number of uniques. So every time unique go up, so if it's the same, not if the same, each time you do, for every one, you have to add a number of uniques. So yeah, it's the same idea, but without using map, without using list. Okay, I agree. This is a better solution. Oof. This is the official solution, which does not require a counter. We use a separate variable to record the number. Yeah, we sort nums first. Then we just record the number of uniques encountered so far. Then for each number, the number of operations to bring the number down to the min would be the count of the uniques, current uniques. So straightforward O and log n plus n is the same, but it will be faster. Which means we'll go arrays.sort nums int unique count, okay, int res for int I equal to 1, I smaller than nums dot length, I plus plus. If nums I is not equal to nums I minus 1, so that is unique. So unique plus plus, right? Otherwise, we say rest plus equal to unique count. Then at the end, I will return rest. There we go. That is the official solution. That will be very fast. Yep, about twice as fast. Can't argue with that. Can't argue with that. Alright, so we're done with this. We'll move on. Maximum sum queries. You are given two zero-index integer arrays, each of length n, and a one-indexed. And a what? A one-indexed 2D array. A one-indexed. That is stupid. Queries, where queries I equals xi and yi. For the ith query, I think that's why it's one-indexed. Ith query, find the max value of nums 1, j plus nums 2j among all indices 0 to, what's n? N is the length. So we'll find the max value of the sum of nums 1j and nums 2j, okay? Where nums 1j is larger or equal to xi, nums 2j is larger or equal to yi, or minus 1 if there is no j satisfying the conditions. Return an array answer where answer I is the answer to the ith query. Ooh. Let's take a look. So the first question, we have nums 1 is 4, 3, 1, 2. Nums 2 is 2, 4, 9, and 5. And a query q1 is 4, 1, which means nums 1 has to be larger than 4. All of them, anyone larger than 4, larger or equal to, so it's only 1, so it's 6. So q2 is 1, 3. So basically anyone. So the second one has to be larger or equal to 3. So 4, 9, 5, right? So we do this, that'll be 10. Q3 is 2, 5, larger or equal to 2, except from this. Everybody else except from this, larger or equal to 5. So only this and this. So it's only 7. Okay. It's like a query. But if you do it for every single query, which you have, so n is 10 to the 5th, query is 10 to the 5th. Yeah, they gotta be, oh my god, look at this. Look at the hints. You got 5 hints. It's not difficult if you do it brute force, okay? You do a brute force, we will be O query is m, all right? O query is m, and then O n. So m times n, right? M times n is the result. But we can do better, right? We can do better by maybe we can rearrange the queries. I mean, we probably shouldn't rearrange num 1, num 2. But leave them as is, but we can rearrange queries, right? Such that if we can progressively eliminate stuff, that will be interesting. Or if we can larger than, right? And now, what does this reminds me? A 2D, that's what it reminds me. So let's say num1 is x. So we have 1, 2, 3, 4. Okay. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. So first is 4, 2. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 4, 2 is this point. 3, 4, 3, 4 is this point. 1, 9 is this point. 2, 5, 2, 5 is this point. Okay, so these are the points, right? Then query is also points, right? 4, 1. 4, 1 is the point. Let's go hollow. So what we're trying to say is to find the sum of the axis that is to the up, right, and diagonal. So like nothing within this will count. I mean, we can create the sum. This is 6, right? This is 7. This is 7. And this one is 10. And mind you, everything on this line, I think, has the same. 这样吧。Oh, that was my shorts. That's fine. Yeah, so if we say x plus y is equal to the same value, right? That's equal to 7. Then everybody will be on the same. They all have the same slope, right? So in this one, it's just gonna be right? That is this line. This is gonna be this line. This is gonna be this line, so it's the 6. Right? So these are just, we just have these lines, one by one, one by one, one by one, have these lines. Now the question is, given a required position, which means we can, hold a second, which means we can rearrange this into the slope, not the slope, the intercept, right? So nums1, nums2, we can go into the intercept, will be 6, 7, 10, and 7. We don't need repeat. So these are the intercept. And what we're looking for is a block, right? So this is the block. Is it any points inside this block? And what we're looking for is the one like outside, right? Outside. So what we want to see is the largest slope above this line, right? Which means for each of this, for each point, we can compute its slope, right? We can compute its slope. We know the slope is k is equal to 1, right? So it's just going to be b equal to x plus 1, x plus y, okay? So now we say is 4. So this is 4 plus 1. So b is equal to 5. So this point represent a line like that, right? A line like that. So any point is beneath it. I mean, it still works, right? You need to know if it's inside this. If it's inside. Which means anything that's bigger is definitely, it's definitely outside, above it. So for this case, we can just pick the largest. Right? We can just pick the largest. That is not true. It's only pick as 6. I don't understand. X has to be large. Oh, X has to be. Oh, hold on. That is not true. That is not true. That is not true. It has to be this box. My bad. Has to be here. In this box. Right, and each one will go upright, top right. We need to make sure it's landing in the top right. Top right. Okay. So if we go for each query, it will be very hard to find which one is inside. But well, what if we go from the numbers? We go from those first to find out what I can be. What is my, limit? But still, that's... We sort based on something, right? We sort, let's say we sort based on X. Nums1, nums2, let's sort, okay? If we sort num1, num2 based on X, what will we have? Then we'll have 1, 9, 2, 5, 3, 4, and 4, 2, right? 1, 9, 2, 5, 3, 4, 4, 2. Wow, it's a beautiful.
It's 4 million.
Oh. 4 million.
That would be my dream. It was a 4.
Ooh, how many bedrooms?
Only 3, which I'm confused about.
Only 3? I saw like 2 floors. What are these rooms then? Giant garage.
Oh, there's an office.
Office.
Wait, optional 4th bedroom.
Optional 4th bedroom.
Oh yeah, that could be the guest.
Guest,
This is my dream home.
Oh, your dream home. All right. $4 million dream home.
Oh yeah, it's there at the edge. That's why.
Ah.
Look at that view.
Beautiful view.
Mountain.
For $4 million was the mortgage monthly.
Estimated 25,000.
Monthly.
I don't know. That's just estimated month. I guess how much you depends how much you put down.
Oh my god. Oh, we're very far away from that. All right.
Well, we can dream.
We can dream, but now I need to get back to reality. La realidad.
Wow, in 2020 it was only 2.5 million.
Oh.
Skyrocketed in 20 years after the pandemic.
So yeah, now we have these points, right? We arrange them. So the queries, right? The queries. What if we arrange the queries also from small to large? So the queries is 1, 3, 2, 5, 4, 1. So let's say 1, 3, okay? So we want the thing at least bigger than 1. So we get that? And we need the thing bigger than 3. Oh, how would you do that? Bigger than 3. Bigger than 3. Then you see something that's not bigger than 3. Right? There's something that's smaller than 3. But they might have a bigger total sum. Damn. I mean, we're going to do 2, 5. Then we know it's starting from here. But the y-axis is kind of we cannot do, right? Because we don't know. We can only sort based on 1. How are we going to deal with the other one? And then you also need the largest. The many things is happening. This many things is happening. How about uniqueness? There's no saying of uniqueness. Yeah, max sum query. I don't want to keep doing this today. I have something else to do. All right, I will stop right here. And yeah, that's I keep thinking about it in my dream. I'll see you guys tomorrow.